Hey, welcome. Hello guys, how you doing? This is another video for showing the solutions to the exam. So let's begin, let's jump into it. You have a right triangle, this configuration shown in a picture, and two options, option A, option B, showing you information about the right triangle, and you have to find all the missing information. Okay, so in option A, you already know that the angle with vertex in A is 30 degrees, so you can mark it here, 30 degrees, and the side B is equal to 6, so you can put it here. And about this angle and the adjacent leg to this angle, so you can use both tangent or the cosine because you have information about the adjacent leg. So let's use the tangent. The tangent of 30 degrees is equal to the opposite leg A over the adjacent leg B, which is equal to 6. And you already know that the tangent of 30 degrees, because the 30 degrees is one of the known angles, is equal to 1 over the root of 3, equal to A over 6. And you clear for A in this equation, just pass the 6 multiplying. So you have 6 over the root of 3 equal to A. And this is the value of A, okay? And now that you have the value of B and the value of A, you can easily use these two to calculate C by the Pythagorean theorem, yes? So C squared is equal to A squared plus B squared. This is a very easy calculation. C is equal to A squared is 36 over 3 plus B squared is 36. Root of all this equal to 36 plus 102 over 3, root of all this, and this is 138, yes, over 3. So this is C. And now you have everything. The other angle, of course, is 60 degrees. Okay, now let's do option B. Okay, I'm gonna erase here. This information is from option A. And now let's do option B. Okay, as you can see, it's actually very easy to solve right triangles. The only thing you have to identify is the information you have, and based on the information you have about this triangle, you can follow a strategy using cosines, trigonometric radius, or Pythagorean theorem in right triangles. Okay, in next stage, what we are going to use is a generalization of the Pythagorean theorem and as trigonometry. Okay, for solve not only right triangles but all kind of triangles. Okay, so in option B, both A and B are 13. Okay, so this means this is 13, this is 13, and this means this is an isosceles triangle. So if these both have the same length, this means this is an isosceles triangle. You can go straight forward for the tangent of this. This is the tangent of, let's call it A. Tangent of A is equal to 13 over 13, which is 1. Which angle gives you a 1? What is the inverse tangent of 1? You know already it's 45 degrees, okay? And since this is isosceles, this is 45 degrees. And actually, you don't even have to calculate the tangent. In the very instant you already know this is an isosceles triangle, you can immediately say that this angle, these both angles are of 45 degrees, okay? And the only thing missing is the hypotenuse. So you can go very quickly and apply the Pythagorean theorem. And once you perform this calculation, you are done. Okay, so these both problems were a gift for you, so you can achieve some easy points. Let me erase all of this because the fun actually begins in the second problem and so on. The second problem, let me read it quickly. Come on. it says in a right triangle, here it is, very clearly, in a right triangle, the length of one of the legs is x and the other is 2x, while its area is 400. Find the length of all sides. Remember that the area of triangle is base multiplied by height over 2. Okay, that's just a reminder. The problem doesn't provide a picture, so you have to do your own picture, and that's a very important part of the problem. So you have a triangle. It is a right triangle, so you can begin just by drawing this, a right triangle, okay? And it says one of the legs is x and the other is 2x. One of the legs, if this is the right angle, you know that the opposite angle, the opposite side, sorry, it's the hypotenuse. So these both are the legs, and one of these legs is x and the other is 2x. Doesn't matter which one is 1, okay? The thing that matters is one is x and the other one is 2x. And you know that the area of this triangle is 400, okay? It's the area, you need squared, okay? This means that the area is 400, but you know that the area of any triangle is the basis multiplied by the height. And in this right triangle, any of the legs can be the basis and the other one the height, okay? So you can choose any of these. Let's say this is the basis, x multiplied by height, 2x divided by 2, okay? So these two multiplying with these two dividing cancels out. So the area is x multiplied by x, which is x squared, but the area is also 400, so x squared is equal to 400. And you have a very quick equation to solve. You have two solutions. You already know from algebra that one of the solutions is 20 because 20 squared is 400, and the other solution is minus 20. But this is a triangle, and the sides of a triangle cannot be negative. Okay, so we choose this solution. Okay, so one of the legs is 20 and the other is 40, and that's it. Okay, it was actually easy. Just the only thing you have to do is construct the equation. Okay, just put together these ideas of how to calculate the area and the information the problem is giving to you. Okay, let's do the next problem. Problem 3. Problem 3 actually provides you with a picture. Let me draw it quickly. Okay, you can put your doubts in the comments, guys. Remember, a class without doubts is a class where nobody is learning. So the picture for the problem 3, this is a right triangle. Imagine I draw a perfect right triangle, and this is A, this is B, this is C, and there is another side here, and this meeting is called E, and this side is 10, this side is 14, and this is 16, and it says the triangle ABC, it's a right triangle with the right angle at A, okay? Find the length of DC, find this length, okay? So we have to find the length DC, okay? So basically we are looking for this, let's call it X, and you have only information, check this out, you have only information about the sides. So I told you this, when you have information about the sides, the strategy you surely have to follow, or a very good strategy to begin, is use the Pythagorean Theorem, okay? So let's focus on triangle ABC, okay? Or better in ABV. Look at the triangle ABV. This is also a right triangle, the ABV, and you have this leg, and you have the hypotenuse, so you can easily calculating this missing side, AD, okay? So this side is, let's call this alpha, and let's call this side beta, and this delta, okay? So This is the hypotenuse. Okay, so the hypotenuse squared is equal to the legs squared. Okay, alpha plus delta squared. So this is 14 squared equal alpha squared. This is 10 squared plus delta squared. And delta squared is the one we are looking for. So delta is actually 14 squared minus 10 squared root of that. Okay? Do this calculation and you have the delta. Okay? And now let's focus on the triangle ABC. And let's call this gamma. Okay? This side gamma. This PC side gamma. And the side AC, which is one of the legs, this is the hypotenuse of the triangle ABC, and this is one leg, this is the other leg. So this leg is actually delta plus x, and we know delta, so the only missing part is x. And you have the from the Pythagorean theorem, gamma squared, which is the hypotenuse, is equal to alpha squared, one of the legs squared, and the other squared, which is delta plus x. Delta plus x squared. This is a number. This is actually a number. So the only thing here is calculating, clear this equation for x, and you are done. Okay? So let's substitute. Gamma squared is 16 squared equal to alpha squared is 10 squared. Yes? Plus delta is 14 squared minus 10 squared root plus x all that squared. Okay? So let's put this 10 here. So 16 squared minus 10 squared is equal to 14 squared minus 10 squared root of that plus x. And I think you can do this very easily because in the exam you were allowed to use calculator, so you sure didn't have problems to solve this. Okay, let's put the root in the other side. 16 squared minus 10 squared root of that equal to 14 squared minus 10 squared root of that plus x. So x is equal to 16 squared minus 10 squared root of that minus 14 squared minus 10 squared root of that. Okay, you can see, yes, you can see. So this is the answer. Okay, this is the only thing you have to do is compute this number, do the calculations, and the fun has ended. Okay, well, okay, take a break. Next problem is coming. Check if you did this the same process. And actually, lots of you got this question, got this problem right. It was actually not that challenging. Just have to identify the two triangles. Okay, now that was problem 3. Next is problem 4, and the problem 4 also provides a picture. So let's go here, and you have this picture. Oh my god, maybe something like this, and like this. Okay, maybe more like that. Okay, yes, because you have A, B, C, D. Okay, and this is 6 and this is 9. And the problem says in the figure below, AB and CD are perpendicular, and AB and CD are perpendicular to BC. Okay, so this is perpendicular, this is perpendicular. Okay, so we have a right triangle right here. Okay, And the size of the angle ACB is 31 degrees. So you can write it there. Find the length of the segment BV. BV. So we are looking for this. Okay. As you can see, we have a right triangle right here, and we actually have this other right triangle. So these two right triangles, and you have information about this angle and this side. So using trigonometric ratio is a strategy to follow. So this is the right angle. This means this is the hypotenuse, okay, and this is the opposite leg to this angle, okay. So we can use this information. If I use the sine, because I have the opposite leg, if I use the sine, I will know the hypotenuse. But I think that's not something will be useful for us, because if we know this, if we can achieve or manage to know this side, you can use this information to solve this other triangle. So it's actually better for us to use the tangent of 31 degrees, because the tangent involves the opposite leg, which is 6 over the adjacent leg, which is this one. Let's call it alpha, okay? So it's alpha. So solve this for alpha. Alpha is 6 over tangent of 31 degrees. And now you have this leg is 6 over the tangent of 31 degrees. And this is 9. So you have this leg, and this is the opposite to the right angle. So this is the hypotenuse. This is C, so let's call this C. And actually you are done. Once you identify this, it's actually a very easy problem, because C squared, this C squared is the hypotenuse, is equal to the 9 squared plus the alpha squared. And you know the alpha, okay? So this is C squared is equal to 9 squared, which is actually 81, plus 36 over the tangent squared of 31 degrees. And the root of this is the value you are looking for, okay? It's the value you are looking for. So actually, once you do this computation, again, a very easy problem to solve. So actually, guys, as you can see, the only thing you have to do to solve my exams is just think geometrically. Open your mind, your third geometrical eye, to see how to turn around the picture, how to make lines, how to identify the right triangles, the strategy you have to follow. And actually, the problem becomes so easy. Okay, that was the fourth problem. Let's do the last problem, the fifth problem. Sorry. Let me read this. Okay. What's next? This problem doesn't provide a picture. Let's read it. In a right triangle ABC, okay, a right triangle, we can begin with that. Right triangle ABC. So you already have a picture. In a right triangle ABC with angle A equal to 90 degrees, maybe ABC, okay, equal to 90 degrees. Find angle B and C, so that we have a condition. Find the angle B. We are looking for the angle B and the angle C, so that the sine of B is equal to the cosine of B. So this is a condition you have to meet. This is a condition. What are the angles that satisfy this condition in a right triangle? Well, we don't have too much information about the sides of the right triangle or their angles, but this is a very specific condition. So let's call this is A, the angle A, so this is A, C, and this is C, B, and this is the side B. Okay, so we have just put names on the sides, okay? So the sine of B, this is the angle B, the sine of B is the opposite leg over the hypotenuse. So this is B over A equal to the cosine of B the cosine of it is the adjacent leg over the hypotenuse, A. So this equation have A has A in both sides dividing. So this means B equals C. Okay? Because you can cancel out this just by multiplying A in both sides. Okay, as you know from algebra. So this triangle is not any triangle. It's a triangle. If this triangle satisfies this condition, this means B must be equal to C. So these both sides are actually the same length. And if they are the same length, they are an isosceles triangle. Therefore, triangle ABC is isosceles. Isosceles. Oh my God, who is right? I hope this is the right spelling. Okay, and this means if this is an isosceles triangle, these both angles are the same, and if they are the same, you already know these have to be 45 degrees and 45 degrees. Okay, because they have to add up to 180 degrees. Okay, so actually another easy but kind of tricky problem. Okay, so this exam was actually testing your insight into geometry. Okay, in how open it is your geometrical eye. Okay, your geometrical mind. So this was the last problem, but there was an extra points problem as always in my exams. So who tried it? Put it in the comments. Who tried the extra points problem? I always try to put extra points problem a little bit tougher, a little bit challenging, more challenging than the actual problems in the exam, because I want you to. I am pretty sure that the young students need challenge, okay, to solve and to test themselves, okay. So the extra point problem was actually had more value than all the rest of the problems individually, and provides a picture. Let me use my marker. So this is the picture. There is a building here like this. This is like a house or something, and you have this. It says standing at point P. This is point P. You observe that you must look up at an angle of 45 degrees to see the top of the pole. So this is a pole, okay? And you have to look up an angle of 45 degrees. This is in the picture. To see the pole, the top of the pole. You then walk away from the building to a distance of 10 meters to point Q. Point Q is here in the picture, okay? And it's provided with this angle, okay. And from here to line up to the pole makes an angle of 30 degrees to the horizontal. How high is the top of the pole? So actually we tried a very similar problem like this one in class. So it gets away 10 meters, so you can say this is 10, and you can actually remove from the picture all the non-mathematical objects and make an abstraction of the problem. So your sketch of the problem becomes an abstraction of the problem, and the problem is actually find this side of this triangle, okay, because poles are perpendicular to the ground, okay. So this is a right triangle, and basically you are looking for this, let's call it Y, okay. Why? Because you actually don't know these other sides, but you can name this side X, and this is, if this is X and this is 10 meters extra, so this all side is X plus 10, yes, because this is 10 extra length, okay. So you have two triangles, and you have information. You're looking for one of the legs, the opposite leg, and you have information about this part, okay, of the adjacent leg. So I think use the tangent is a strategy to follow, because you are not actually interested even though have information about the hypotenuse. So use the tangent is the thing you have to do. And look, if we focus on this triangle, this the tangent of 45 degrees is actually y, the opposite leg, over x. Okay? Over x. And now focus on this other triangle, the larger one. And the tangent of 30 degrees of this is the opposite leg, which is y, over the adjacent leg, which is x plus 10. And what do you have here? Yes? The tangent of 45 is a known angle, and the tangent of 30, actually we used these angles in the previous problems. So the tangent of 45 is 1. So this becomes 1 equal to y over x, and this becomes 1 over the root of 3 equal to y over x plus 10. And you, voila, you have a system of equations, okay? This is equation 1, this is equation 2, and in algebra you learn how to solve this kind of systems, okay? So for example, here you have x equal, if you pass this x multiplying, you have 1 multiplied by x, which is x, and you will have x equal to y, yes? If you have 1 equal to y over x, you have x equal to y, yes? Just pass this multiplying. And here you have something similar. You can pass this multiplying here and this multiplying here. So you have, if 1 over the root of 3 is equal to y over x plus 10, this is x plus 10 equal to root of 3y. And you can solve this. It's actually not that hard, okay? You can solve for y. And once you know y, you know this, you have solved the problem. It wasn't that hard, don't you think? And well, I don't want to take you off the pleasure of solve this system of equations, so do it by yourself, please. Share your answer in the comments or in Classroom or in Discord. Remember to set a phrase for us to grow as a class, as an educational community. And I think this is it, guys. All this for this video. Oh my god, a little bit large. Well, let's stop here right now. Come on. Bye.